There's plenty of evidence to suggest that one of the biggest concerns for lower limb prosthesis users is excessive perspiration. Now this can lead to problems like keeping the prosthesis on, but also a deterioration in skin health, and this in turn can lead to a reduction in the quality of life. Imagine then a solution where we have a breathable interface and a ventilated socket that is proven to reduce perspiration at the skin interface layer and also improve skin health and improve people's quality of life. I'm Richard, a clinical specialist prosthetist with the Osler Academy, and today we're talking about the AeroFit system. Now, the AeroFit system is a combination of a breathable interface and also a ventilated socket. And it's these two components working together that absolutely address the problem of perspiration at the boundary of the residual limb and the prosthesis. Now, the AeroFit liner is a very clever piece of technology. Let's take a closer look. So here I've turned the AeroFit liner inside out, and you can see these different zones. And when we have a closer look again, we can see that these zones are what we call the ventilated area that we see here, and also the vacuum safe zone. If I go back to looking at the liner again, we have this medial panel in the vacuum safe zone, which is where the more sensitive medial soft tissues of the transfemoral residual limb are. And also this distal vacuum safe section, which is where we are allowed to have the effective suspension from the sealing system in association with passive or active vacuum, such as Unity. But when we go back again and have a closer look at this ventilated or breathable section, we have these micro holes on the skin surface layer, and there's over 100,000 of these holes that then pass through the surface layer into a three-dimensional mesh which sits behind it. And it's in this mesh that allows perspiration, moisture, water vapor to travel in different directions within the interface. And during loading and compression during the normal gait cycle, there is compression of the interface, and this allows for exchange of water vapor and air and moisture, and ultimately allows perspiration and water vapor to pass through the fabric cover layer, which has a special wicking treatment to draw moisture away from the surface. And then from that point on, moisture and water vapor is vented through into the socket environment. The second component to the AeroFit system is the ventilated socket. And on this direct socket transfemoral version, for example, you see we have these vents placed in strategic positions. If we take a closer look, we can see inside the socket where these vents are positioned in a way that they don't protrude into the surface of the socket, making it uncomfortable for the user. But the water vapor that has vented the liner is then able to exit the socket into the environment, helping manage the perspiration levels inside the socket. The evidence tells us that by using the AeroFit system for transfemoral users compared to non-ventilated systems, that we see an absolute reduction in the amount of perspiration inside the liner. And this in turn leads to an improvement in skin health, which again in turn leads to an improvement in people's quality of life. Now this means users aren't needing to engage in other coping strategies, such as constant removal of the prosthesis during the day and drying down their skin. The AeroFit system is demonstrated to improve these situations. AeroFit is available for transfemoral users and is available in the sealing configuration in standard form, sizes 25 to 55 centimeters, and in conical form, sizes 23.5 to 40 centimeters. The AeroFit system comprises of a breathable interface and a ventilated socket, and is proven to reduce sweat within inside the liner, improve skin health, and improve people's qualities of life. Now, for more information on the AeroFit and other products in our portfolio, please visit us on the usual channels.